close all these extra windows that I have open because this is not my actual laptop. This is another laptop, and I'm going to actually send you guys the LeetCode links. So, we're going to be covering a couple of easy level LeetCode questions. And honestly, like when I first saw these problems, I was like, oh, I know how to do this, so easy. And then I started doing it and I realized like, hey, there's probably a better way to do this. And there was, lo and behold. So this is the first one that we're going to be starting with. And I'll send the link in the chat here. There we go. So it's the two-sum problem. For those of you that don't know what LeetCode is, it's basically like a site on the internet that has a bunch of technical difficulty questions that a lot of people get asked at technical interviews for. And, you know, these questions kind of gauge your skills on how you can respond to problems and how quick you are of a thinker on your spot. These are more designed to vet you of your programming skills, I'd say. So, yeah, just let me know. I know these concepts, some of these are hard to explain. Like, you know, when you're driving a car, you know how to drive it, like, you know how to drive it like in your head, but when you try to explain to someone else what you're doing, it's a little bit more difficult. Like, oh, I'm putting my foot on the accelerator, I'm, you know, pressing the brake, you know, that sort of thing. Same thing with code. It's not as easy to explain. So I do understand, like, please let me know if I'm not being clear or coherent. Just tell me, I'll stop and clarify. I'll go back. Just let me know. Okay, so I guess I'll start by sharing my screen. Oh, I have to share my screen first. Okay, one second. Yeah, and it's nice to see everyone here. Window, there we go. Okay, so I'll actually pull this chat out. Ooh, which window is it sharing? Can you guys see my LeetCode screen? Oh, I didn't even pull it out, that's why. Okay, there we go. And I'll make this really small. Yes, okay, perfect. I'm just gonna minimize this so I can still see the chat in case anything goes wrong. Okay, there we go. And I'll keep this over here for now. And I'll change this to Java. So I put the link in the chat. I didn't minimize this window, of course. Okay. Here we go. I wonder if I can, yeah, there we go. That's perfect. Great. So let's get started with the first question that we're going to be tackling today. So this question is called the two-sum question. Basically, hi, nice to meet you. Okay. Yeah, nice to meet you. Okay, so we're going to be covering the two-sum question today, and it's a pretty common question to be asked. I think this one is a very, you know, it's very common to be asked this question at some point in your life as a programmer. So basically what the two-sum question is, and, you know, I won't read it word for word exactly what it's asking you, but you're given an input of an integer array, and you're given a target also as input. And you have to find two values within your input of integer array that equal to your target. And when you're not returning those two values themselves, but you're returning their position within that original integer array. So in this example, you have an integer array of 2, 7, 11, and 15, and you have a target of 9 as your input. So what your job is to find the two values within this array that add up to 9, which in our case is 2 and 7, and then return the output as the position of 2 and 7 within the original array. So 0 because 2 is at index 0, and 1 because 7 is at index 1. Okay. And now I think the low-hanging fruit, if you will, of answering this problem is to brute force it, essentially. Like, try every single combination and hopefully you'll end up with the right one. And I mean, like how that would look like. Oh, sorry, I have the French Canadian. I don't speak French. I don't know why it always does this, but like, I would love to speak French, but I don't. Anyway, sorry. So the brute force method would essentially be like one for loop on the outside and another for loop nested within it. And the first for loop would be, you know, looping through every single array value from the index of 0 to n minus 2. And the inner for loop would be going from 0 to n minus 1. And I'll explain why in a second why we do this. So this is the brute force method. Again, maximum amount of comparisons. So what this brute force method is doing is basically it's taking the first value of the index array and it's comparing that value with the rest of the index array, with the rest of the values within the index array. So it will first take 2 in the outer for loop, and then compare it with the rest of the values within the index array and return if it finds the matching pair that equal to your target. And this works. It's functional for a smaller data set like this. This is only 4. But let me show you what happens if I work with an array like this. Okay. So I'll use the same array. I'll just make it backwards. 15, 11, 7, and 2. Okay. And if we're using the brute force method, we have 2 for loops, one going all the way from 0 to n minus 2, n minus 2, and then the inner for loop going from 1 to n minus 1. Okay. Oops, that's supposed to be da-da-da. Okay. Let's say our target here is also the same. So it's a target of, forgive my typing, target of 9. Okay. Now let's look at the number of comparisons. Well, like just eyeballing it, we know that the output we're going to have to return is 2, 3, because 7 and 2 is equal to 9, and their positions 2, 3 of the index. But if we were to put this in a for loop, nested for loop like this, what we'd have to do is the first thing we do is we take the 15 and compare it with the 11, not get 9, with the 7, not get 9, and with the 2 and not get 9. So that's already 3 comparisons within our first pass through the for loop. Then within the second pass, we take the second value and compare it with the rest of the values within the array. So 11 compared with 7, not get 9, 11 with 2 and not get 9. So we started with 4 elements. We did 3 comparisons. Now we're starting with like essentially 3 elements. We're doing 2 comparisons. And finally, at the very end, we're going to get the 7 and compare it with the final value 2, realize it is a pair. It's still a comparison though, because we still need to find the values. And then, that equals a total of 6 comparisons. Is everyone with me so far, by the way? Any sign of life? Yep. Okay. Yes. Great. Okay. Okay. Yeah. So this is a method that works. But the problem with this method is like, what if, like, from the start value to the end value, you actually have 100 elements? 100 elements start from this value to this element. Well, you're not starting at 3, you're starting at 99 as a countdown, and you're going all the way, oopsie, you're going all the way down to 2 and 1 if your values end up being the last 2 in the list. So that could be like literally thousands of comparisons. I'm going to say thousands. Yeah, that sounds about right. Thousands of comparisons. And for like 100 elements, that's not efficient at all. So that's why I call it like the low-hanging fruit of approaches. A smarter approach would be to solve this problem in one pass of the array. So if you have 100 elements, the ideal situation would be at most to do 100 comparisons. Okay. So now the question remains, how do we solve this problem? How do we only pass through this array once and get the answer that we want? And this is where your data structure knowledge comes in. And for those of you in like first year, don't worry too much about knowing this stuff. Like, it comes with time, it comes with experience, and it comes with research. Today, we're going to start with that time and research. I guess I'm going to introduce you to maps if you haven't seen them already. So a map essentially is like a data structure that will help you to solve this problem. Ideally speaking, when we're trying to solve a problem like this, we want to make sure that, like, okay, when you're looping through an array once, the thing with arrays is that you don't have visibility of the numbers that you've passed and the numbers that you will see further down the line. So if I'm looping through my array and I'm right here, I don't know that I've passed a 2. I don't know that I've passed an 11. I will pass an 11 in the future. Actually, I don't know very many. I don't think you can't do that with arrays. You can't. But the thing is that if you store the numbers that you have passed in your array in a data structure, you can basically tell your program to prepare for the future. So what I mean by this is, like, for example, you're passing through your array, you pass through the first index, you pass a 2. And you know the complement of 2 for 9 is 7. So you know that if you find a 7, you already have a 2. You already passed a 2, right? So the idea here would be to store this 2 somewhere where you can just call on it when you need it. Is that making sense to everyone so far, what I'm saying? I feel like I'm just rambling in silence. Yes. Okay. Thanks, Gary. Okay. So the best way to do something like this would be to store this past information would be to put it in a data structure that holds onto it and waits for you. And that would be a map. So let me give you a little bit of an analogy. So if you're working with an array, it's kind of like looking at a textbook with no numbers. So yeah, like if you you don't know if a value exists within that array, or where to even find it within that array. In order to find an element within an array, you'd have to loop through the whole thing and end up at it, right? Um, so it's kind of like a teacher giving you a textbook with no numbers and saying, hey, like flip to your chapter with Barney. How would you find out that that textbook had Barney, or which chapter it was at? You'd have to flip through every single page, right? A map is sort of like a textbook with not only numbers, but with a table of contents. Numbers and table of contents. Basically, it's a data structure that if a teacher tells you to flip to the chapter with Barney, all you got to do is like look in the table of contents, see where it's at, and then go to that page number, right? Same thing with the actual map data structure. All you got to do is look inside that map, see if that value exists, and then find the value that the data that key is attached to. Is that making sense to everyone? Yes. Okay, great. So let's go ahead and implement this. Great. I'm glad to hear it. So the first thing I'm going to do is I'm going to make our map structure. And I'm going to say integer, and I'm going to call it nums passed, because this is going to store our numbers that we've passed in the array. So it's equal to new hashmap integer. Okay. And basically, this implementation is a key value pair. And what I mean by that, key value, it's like a textbook chapter and page number. So this tells you what it is you're looking at, and this is the value that you want associated with that key. So in our case, what we're going to store as the key is going to be the value that we've already passed. So our array nums at index whatever it is, I'm going to say x, and our page number, the position where it is inside your int array, is going to be x. Okay. And let's go ahead and implement that one for loop passing through the array. Okay, so for int I is equal to 0, I is less than, oh yes, nums.length, sorry, and I plus plus. Okay, so we're passing through our array, right? This is what we're doing with this loop here. I'm going to get rid of this brute force method. Okay. And what we're going to do, first of all, is we're going to see if the numbers passed contains the value that we're suddenly. Okay, so actually, let me reverse. The number that we're looking at right now, I'm going to call it int num, is going to be nums at index I, right? Because that's the number that we're extracting. So if we're in the first iteration of our loop in this array, we're going to get the value 2 here. Okay. We're also going to want to find the complement here, which is going to be, sorry, I didn't put I plus plus there, oopsie. Our complement, which is going to be our target, which in this case is 9, minus num. And if we're talking about our first iteration, we're going to be talking about the number 7, right? Now, the next step is to see if within our nums passed array, if we've passed a 7 already within our array. So we're going to check that. So if nums passed dot contains key, and I'm going to say complement, then we know we have our answer, because the index of 7 and the index of the number that we're currently at, that's going to be what our array is. So I'm going to create a new array here, and answer is equal to new int 2. You don't have to do all this. If you know a shorter way to implement, I'm just doing this so you guys can see what I'm doing. Our first index is going to be the index where the numbers passed exists. Okay, which is going to be nums passed dot get, and we're going to get the value of our complement. So if we pass 7 within our array, we're going to return not 7, but the position inside the array index that it was originally inputted in. Okay, and then here we are going to put I, because this is the index where the current number that we're passing through exists at. And then we can return just there, because for every input, there's only one answer. So now if we, I think I'm going to need another array return statement here. Okay, yeah. If we end up passing this 2, and we know that we haven't passed the 7 within the array, we want to make sure that we go ahead and document this 2 in arrays that we've already passed. Is that making sense? We want to add that to our nums passed array, because we want to say, hey, if you ever encounter a 7 in the future and you need an extra complement, well, there's a 2. Okay, great. So let's go ahead and add that to our array. Add that to our map, sorry, add that to our map. So I'm going to put nums passed dot put, and I'm going to put the value itself. So this would put 2 into my numbers passed and I as the value. So key value. Okay, and then once my for loop is through, I think I just need to return an empty int. Oof. You know what? I can put the declaration of this up here. Oh, and I have a lot of okay. So, and I can just return answer at the end, because it will contain our documented answer. So now if I submit, oh, okay, 1 second. Didn't realize that. I hope that's the right password. Okay, 1 second. My internet, everything is breaking down today. 1 second, it's on my previous laptop. Yeah, this is not supposed to happen when you click submit. 1 second. Let me get the password from this one. Okay, 1 second. This is what happens when you change laptops randomly, because for whatever reason your unmute button isn't working. It's a perfect storm. Huh, funny, I was putting that exact password in. Okay. Oh my God, of course, okay. Yay, okay, there we go. Never. Leave me alone. Okay. So can I submit? Oh my God, for real? Okay, 1 second. You know, I thought I didn't need anything. 1 second. I do have a password manager, but my internet was like, I have another laptop, and for whatever reason, the internet wasn't working on that laptop. So yeah, here we are. And it has a password manager. Okay, please work with me now. Okay, there we go. So if we submit now, it should all be fine. Hopefully you haven't forgotten everything. Okay, yeah, there we go. Everything I just talked about. Okay. So do you guys understand what happened in that whole situation? Is there any part that was unclear? All was unclear, or all was clear. I know it's a little bit complicated. It's all unclear. Oh no. Okay. I think I need a one-on-one. I'm not sure. I know it's really complicated, but that's as simple as I could possibly explain it. I'll try. When did we populate the hash map? So here, what we're doing, so if we look here, if we're looking here, when we're in the for loop, when we're passing through the for loop, we're trying to see if we've already passed the number that is the complement to the number that we're looking at. If we haven't passed the number that's the complement, we add it into our hash map right here. If nums, we put it right in here, nums passed dot put. Because if it does contain, so if we pass a number that has a complement that we've already passed, essentially what we're doing is we're automatically returning right away. We end the for loop right there. Is that making sense? Okay. So Ophir, I'm going to try one more time at a high level, just to see what we did in the code. Basically what we're doing is with this method, what I'm doing is I'm looping through this array only once, because, if we compare all the elements to each other once, it's like too many comparisons. So I'm looping through this array once, and for each time I'm passing through our array, I'm looking at my hash map and seeing if I've already passed a number that's a complement to the number that I'm looking at. So in this case, I'm passing 2. I'm wondering if I had already passed 7 within my array, right? If I have passed 7 in my array, great. If not, I'll continue. I'll add this 2 to my numbers that I've passed, and I'll continue looping through the rest of my array. Now, when I get here to 7, I can say to my hash map, hey, have I already passed the value 2? Because 2 is exactly what we need to get a 9, right? And if I have passed a 2, all I got to do is say, hey, where in that original integer input was that 2? And I can retrieve that from the hash map and then return it right away. Is that making more sense a little? Okay. I know it's a lot more, it looks a lot more complicated than it is. It's just it's very hard to explain. But yeah, I'm going to try a little harder. I don't know if I can, but I'll try. Does anyone have any concerns about this question? I'm going to take your silence as there are no concerns. Yeah? No concerns. Okay, great. Okay, let's go on to the second question here. I believe it's valid parentheses. Let's see here. Hey, look at that. First shot. Okay, I'm going to put this link right in the chat. So if you guys can follow along too, and hopefully have a computer that has your password manager that doesn't prevent your mute button from working. But yeah, okay. So I'll let you guys get that open, and in the meantime, I'll explain what this problem is. And basically what this problem is the valid parentheses problem. And I think this one is also pretty common among the interviewing world. Essentially, what you're given is a string, and that string is either it's only composed of parentheses. And you have like this round brackets, curly brackets, or square brackets. Brackets, braces? Oh my God. Okay, these things. Okay. And it's your job to determine if the string is valid based on 2 things. Number 1, does every opening bracket have the correct closing bracket? And number 2, are your brackets in the right order? So if we're looking at our sample input here, right, we have an opening bracket and we have a closing bracket and no other brackets. All is good, so it will return true. If we look at this one, we have an opening bracket and a closing bracket for each set of brackets, and they're all in the correct order. None of these brackets are interfering with the other. So our output will be true because we have a valid set of parentheses. In this output here, we have an opening bracket and we have a closing bracket for it. However, the problem is that this bracket is not the complement of this bracket here. That's a problem. And it's not it doesn't match. Therefore, we don't have valid parentheses. And so There's a little bit of a, like this one is also another data structure that we'll be using today called a stack. So I guess my question is, by a round of yays, how many people have not heard of a stack? Oh no, I don't have PowerPoint on this either. Okay. Okay, so I'm taking it as everyone has heard of a stack. That's great, but just for those of you that want a refresher, I'll talk about a stack right here. So a stack is basically, yeah, okay. Pretend this is a pile, this is a ground, and this is a pile of books. Okay. If I want to put a book on this pile, where am I going to put it? On the top, exactly. If I want to take off a book, where am I going to take it from? I'm going to pull it the top, exactly. That's exactly what a stack is. It's a data structure where you can keep adding to the top. And when you remove from the top. Okay. And this is what is meant by last in, first out, because technically, sorry, forgive my writing here. Technically, the book that you put on top was actually the last one that was added to this list, this collection here. But when you remove, it's the first one that comes off. Is that making sense to everyone? Yes, great. Okay. So I'm going to make a text here. Oh, lovely. I had everything set up on that previous laptop. I don't know what was going on with it, but I'm going to just wing it and do the best that I can here. Curly braces and brackets. Can someone tell me if these are valid parentheses or not? Valid. Yes, absolutely they are. And that's the reason is because for every opening bracket, there's a closing bracket, and the brackets are in completely the right order. Can someone tell me if these, yep, there we go. Can I expand this? Oh, let me, there we go. Can someone please tell me if this input is valid parentheses? No, invalid, correct. And exactly. The reason is because we don't have, like every opening bracket does have a closing bracket. However, there's no symmetry among this. Do you guys notice something when you have valid brackets from the point of origin? Do you notice how symmetrical things are from the left to the right? Whereas here, this is our point of origin. If we start comparing letters from the center outwards, it's not symmetrical whatsoever. Isn't that interesting? Yeah. Thursday night. Cool fact. Yeah. And this is where your stack comes in. This is why it's so important to have a stack, because essentially what you can do is you can sort of compare from that point of origin outwards. If I add on to my stack here, like starting from, let me use this one. Okay, so I'm looking at this one here. If I push all my opening brackets onto my stack, and anytime I encounter a closing bracket, I can compare the top of my stack with what comes before it. I can determine if my parentheses are valid. So for example, let me start. So I have a closing bracket here. I'm going to put it onto my stack. I have another I have an opening bracket. I'm going to put it onto my stack, right? I have another opening bracket, and I'm going to put it onto my stack. Now that I encounter a closing bracket, I can pull this one right off and compare it. Does this opening bracket match this closing bracket? This one right here. No. Exactly. So can I say I have valid parentheses? No, exactly. However, if I look at, let me see if I can rewind all the way here. Okay, yeah. If I use this as my comparison, let's see what happens if I have valid input. If I put my opening bracket onto my stack, I encounter another opening bracket, I put it onto my stack. I encounter another opening bracket and I put it onto my stack. And here I encounter a closing bracket. And I can pull that off and compare it. This one with this one. Right? Is it valid? Yes. So then I can pull that off my stack. I encounter another closing bracket, and I can now pull the new top of my stack off and compare it. Does this one match this one? Is it valid? Yes. Oh, I can't see anything here. Okay. And this one, this last element here becomes a new top of my stack. Now, if I enter another, if I encounter another closing bracket and I pull this one off my stack and I compare it, is it matching? Yes. So now at the end of the string, my stack is empty. And what does that mean? It just means that for every closing bracket that I found a matching opening bracket in the right order. So that's what we're going to be implementing in code. Does that make sense to everyone? Have I lost people? Let me know if I've lost you. I'll try again. It makes sense? Okay, great. Okay, great. So let's go ahead and code this in LeetCode. Okay. Okay, so the first thing I'm going to do is I'm going to make a stack. And I'm going to make it of a stack of character. I'm going to call it stack. You know, keep it original. New stack character. Okay. So now that I have my stack, my job is to loop through the string input and either put things onto my stack if they're an opening bracket, or remove things from the top of my stack if they're a closing bracket, and compare and see if it's what I expected. Okay, so I'm going to go ahead and code that in. So for int I is equal to 0, I is less than s dot length I plus plus. So the first thing I'm going to do is I'm going to see, I'm going to extract my character that I'm looking at. So I'm going to call it current character. Current char is equal to s dot char at, and it's going to be the char index I. So this is going to give us the character we're looking at. We're currently looking at. And we're going to see if the character that we're looking at, is it an opening bracket, or is it a closing bracket? So let's go ahead and do that. If current char is equal to, or current char is equal to, or current char is equal to, what am I missing? Square? There we go. If it is an opening bracket, what am I going to do? I'm going to push it onto my stack. So let me go ahead and do that. Stack dot push current char. Okay. And that's all I'm going to do if it's an opening bracket. If it is a closing bracket, current char is equal to, or current char is equal to, or current char is equal to, oh my God. Okay, there we go. What am I going to do? Well, if I find out that the current char that I'm looking at is a closing bracket, I want to try and pull off the top value of my stack. Now the question remains, what if I have an input like this? And I'm looping through. At my first iteration, I know that I'm working with a closing bracket, but if I try, welcome, Frank. Oh, I did? Oopsie. It would still work, but I don't think, yeah, it's not good practice. Thank you. Thank you for that. So if I'm looping through my array and it's my first index and my only index is a closing bracket, logically, we know that this is not a valid input, right? It's not. It's not valid parentheses. But we know we're going to fall here in this else if statement. The thing is, if we try to pull something off an empty stack, we're going to run into a Java error. So we have to have a check here. So if stack dot is empty, if our stack is empty, we know that this closing bracket never had an opening bracket to begin with. So we want to return true. Okay. Oh, sorry, return false. It's not return false. It's not valid parentheses at all. If we pass this check, we want to continue. That means our stack is not empty and there are opening brackets on the stack. What our job is to make sure that the opening bracket matches the current chart that we're working with, right? So let's go ahead and do that. So let me create a new character and I'll call it top, and it will be the top of the stack. So the opening bracket that we pull off the top of our stack. So I'm going to say stack top. And this is essentially a method that takes the first value off the type of off the stack that you have and returns it as whatever data type you have it characterized as. So for us, we have it as character. It's going to return a character that is the top of the stack. And then from there, I'm going to also add in character. I'm going to call this expecting. Now this expecting one, I'm going to make it a default of and basically this character expecting, this is the character that we want the current char to be, depending on what the top of the stack is. So if we pull off this value from our stack, we want the expecting to be the corresponding closing bracket of that opening bracket. Okay, so let me go ahead and set that up. So if my top is equal to opening curly bracket, I'm going to say my expecting is going to be equal to closing curly bracket. Else if top is equal to square bracket, I don't even know, expecting is equal to closing square bracket, right? And since this is the default, I don't need to put another else if in here because by default, it's already this round bracket, right? So we're like, you can say like, it will adjust to whatever data type is there, right? Sorry, it will adjust to whatever opening bracket is there. So now that we know that our expecting is going to be equal to the complement of whatever's on the top of our stack, we want to just check if our current chart is going to be equal to what we're expecting. If it is, we want to continue the loop because it's valid. It's valid. If we get what we're expecting, then there's nothing wrong. We can continue the loop. However, if our current char is different than what we were expecting, we just automatically return false because automatically we know that opening bracket that we got, that we popped off our stack, does not match the closing bracket that we encountered through the loop. Is that making sense to everyone? Complete silence. Makes sense. Okay, great. So if by chance you end up making it through this loop, you have no issues, your current char is always exactly what you were expecting. Your job now is to just, right before you return, to check if your stack is empty. Remember last time we were saying like, where's that here? Yeah, if we have an input like this, I guess. Yeah, if we have an input like this, we're going to pop this onto our stack, but we never encounter a closing bracket, right? What that means is we never popped this off. We never had anything to compare this to. We never had a closing bracket to complement this. So by the time we reach here, our stack isn't going to be empty. It's going to be, it's going to have at least one value inside of it, right? So just to make sure that there's nothing in our stack, if our stack is empty, we want to return true. We have valid parentheses. If we have a value within our stack, it means that an opening bracket never found its matching closing bracket pair. So in that case, we want to return false. Okay, now I think that's it. Can submit it. And then, what did I do here? Oh, I see. Silly me. Okay, and it's accepted. Okay, so I know that was a lot to take in for tonight. There were a lot of data structures that we went through. I really recommend doing research onto maps and stacks, queues, even dictionaries. That will really help you to handle some LeetCode problems. Once again, I do apologize for things starting later than I expected. Yeah, I have nothing I can say that will make that right, but I hope. Yeah, are there any questions? And my internet, of course, is unstable. Are there any questions about LeetCode night? LeetCode questions? Anything that you guys would want answered? Okay, you're welcome. Thanks, Sam. Anybody else? Any questions, comments, experiences with LeetCode? Where do I recommend learning from? That's a good question. I love this. I don't know if he's a YouTuber, but I love this guy named Nick White. He's crazy good at explaining things. Let me see if I can find him. I hope so. I couldn't record with this just because my internet went wonky. Ooh, I can't even not see that. Oh, it's recording anyway. So great. Yeah, there will be a recording. But let me just get Nick White. Do some. Yeah. Also, please. Yeah, that guy. This guy explains things amazingly well. Yeah, yeah, he's great. He's fantastic. He, I don't know, he really knows how to break down a problem, and like, I don't know, it just he breaks down a problem so that you understand it, but he also introduces you to new concepts. Like, so these easy questions that I've tackled, like before I thought I knew how to handle them, but after watching his videos, I was just like, oh, that's probably a better way to do it. You know, he's a really great elite coder, I guess. Yeah. Are there any more questions? I'll put this. I think this will be on our YouTube channel at the end. By the way, Ewan. Oh, sorry. It was what's your name? Sorry, I can't remember. You introduced yourself. I remember that. But oh, I'm glad you enjoyed it. Thank you. OT overtime. Okay. Sorry. Oh, thank you. Yeah, I'm very frazzled. It's a Thursday night. We just did LeetCode, but I will go back and check. It's okay. No worries. You're very welcome. Eva. Yeah, Eva. Okay. Nice to meet you, Eva. Sorry. I'll remember that. Yeah. Is there anybody else that I'll stop the recording here, by the way, because I don't think they need 3 minutes of this. But